Let's look at integration with the help of partial fractions. The first thing we want to do is factor the denominator. That will be x, and those two numbers will be plus 4 and minus 1. Notice that we have two linear factors in the denominator and they're not repeated. That's what makes this an example of case 1. Linear factors that are not repeated. We'll next set up the partial fractions. We're going to have a divided by the first factor, x plus 4, plus b divided by the second factor, x minus 1. For a moment, let's ignore the integration symbol and just look at the partial fractions so that we can find a and b. The next thing we want to do is multiply both sides by the LCD. The LCD in this case is x plus 4 times x minus 1. On the left side, the LCD and the denominator will just cancel each other, leaving us with 5 equals. And then on the right side, we're going to distribute the LCD with the first fraction. X plus 4 will cancel, leaving us with a times x minus 1. Plus, distribute the LCD with the second fraction, and notice x minus 1 will cancel, leaving us with b times x plus 4. At this point, there's a couple different techniques we can use. Since these are both linear factors, the easiest way to attack this problem is to choose clever values for x so that one of the letters will eventually disappear by creating a 0. For example, if we let x equal 1, here we'll get 5 equals a times 1 minus 1 plus b times, again, make x 1. Notice that this factor becomes 0, which means a is going to go away, leaving us with b times 5. Then divide both sides by 5, and we see b is equal to 1. Now we'll do a similar thing, but this time let's let x equal another clever value. Let's assume we want this to go away to 0, so let's let x be negative 4. Then we have 5 equals a times, replace x with negative 4, plus b times, replace x with negative 4, and we now have 5 equals a times negative 5 plus b times 0, that's going to go away. Divide both sides by negative 5, and we get that a is negative 1. So we've now found a and b. We can now rewrite the original integral, which was again 5 divided by x squared plus 3x minus 4 dx. We can set that equal to the integral of a, which we found to be negative 1, divided by x plus 4 dx, plus the integral of b, which we found to be 1, divided by x minus 1 dx. From here, we'll simply integrate. The integral of negative 1 divided by x plus 4, we'll get negative 1 natural log of the absolute value of x plus 4 plus, now the integral over here, we get 1 times the natural log of x minus 1 plus c.